Hello, everybody. We are expecting severe weather today across the lower to mid plains, Florida, and the mid Atlantic. These are going to be a mostly wind and hail threat, but there is a threat for a tornado or two. The date is May 31st, 2025, and let's get right into the forecast. All right, this is our Storm Prediction Center day one convective outlook. We have a slight risk centered over central Oklahoma, and then we have a slight risk in the Chesapeake region in the mid-Atlantic. These are going to be fueled by a mostly wind risk. As we can see here, we have a 15% wind risk in both of our slight risk areas, and then we have a 15% hail risk as well in the same area. And then we have a 2% tornado risk centered over that central Oklahoma risk area as well. Under our day two outlook, we have a slight risk just south of the DFW Metroplex. We have a marginal risk on the border of the Carolinas, and we have a second marginal risk over the Boise, Montana, and Wyoming border. Once again, these are expected to be mostly hail and wind threats with a 5% wind threat in all of our risk areas, and then a 5% hail threat in all of our risk areas, as long as a 15% in our slight risk area just south of DFW. And then there is also a 2% tornado risk in that slight risk area just south of DFW as well. For our day three, we can really see our new pattern starting to come into play with our slight risk moving up here along the South Dakota, Nebraska, and Colorado area. This looks like it could be an all hazards risk, so that means threats include hail, wind, and tornadoes. And then for our day four outlook, last but not least, we have a large 15% French fry sort of risk extending from Texas all the way up to Wisconsin. This is going to be our largest day for severe weather from this pattern. And this is also going to pose all threats, so that means hail, wind, and tornadoes as well. Moving on to our 500 millibar upper air dynamics, we can see what's causing our weather today. So what's going to be the main driver in our main risk area today is this little weird shortwave slash dip in the jet stream pushing southward, starting in South Dakota and ending in our main risk area in Oklahoma later at night. This jet, along with a low and a cold front, are going to provide the trigger for our storms today. And then over in our mid-Atlantic risk area, we kind of see another ejection of our upper level trough, and that's going to be the cause for severe weather in this region today. And then lastly, for our friends down in Florida, we see strong flow across the state that is going to provide ample deep level shear for storms to stay organized. And then we'll sort of see a stalled boundary bringing weather down here. And then we are expecting to see storms bubble up around the afternoon again, and those are expected to go across the state as well. Looking at our visible satellite, we can see our low up here on the Nebraska-South Dakota border, pushing south. And then in our main risk area later tonight, we see mostly clear skies, which is going to allow that air mass to juice up and become more conducive for thunderstorms. Also in our mid-Atlantic risk area, we do see some clearing, so broken clouds. That is going to further allow the air mass to destabilize and produce thunderstorms later today. Here is our simulated reflectivity from our HRRR. As we move on into the night hours today, we can see scattered storms bubble up along the Kansas-Oklahoma border, with some even being predicted to be rotating supercells. And then as we move further, this is expected to sort of turn into a line, and that is when our wind threat is going to sort of increase. But as it goes over the OKC area, we can see scattered discrete to semi-discrete supercells providing all hazards risk. This is the simulated reflectivity for our mid-Atlantic region. Over here along a cold front and our low, we can see scattered storms fire off pretty early in the morning, so before midday, and then we can see them push off and be gone by the afternoon. So these are expected to be mostly wind and hail with not much confidence in a tornado threat at all today. Looking at our Cape and shear model today, we can see that as we go into the night hours when we're expecting storms, we see a small tongue of 500 to 1500 cape, and then we can see our shear vectors are not quite perpendicular to our boundary, but they're also not parallel as well. So that is going to help with that discrete storm mode later. Looking at our significant tornado parameter, we can see that the tornado environment will not be super conducive for tornadoes, but whenever there are rotating supercells, tornadoes cannot be ruled out. In front of our storms, we do see some spin in the atmosphere. And then as we go up to look at our 0 to 3 kilometer SRH, we can see that it is also agreeing that there will be some spin in the atmosphere. So this is one of the many reasons why tornadoes are definitely possible today, even though they are not super likely. Looking at our dew points by time we're expecting storms, we can see that we do have ample moisture up in our main risk area, up to 60 for dew point. That is going to be enough for storms to live longer and initiate. And then lastly, from our convective models, as we go into storm time, we can kind of see where that cold front is going to be up here, where the temperature goes from low 60s to high 60s, and that is going to help initiate storms today. Looking at our weather sounding today, over in the hodograph, we see some curvature in the lower levels and it kind of straightens out in the upper levels. This is definitely a reason why tornadoes are possible today. If we go down here, we can see that there is not a lot of low level shear, but it is definitely enough for a small tornado threat to be possible. And then looking at our helicity, we see 200, so that's definitely enough for tornadoes. And then as we look at our deep layer shear, we see that we have over 35 and 40, so these storms would definitely be able to be organized. Over here, we see that our cape is somewhat low, but model guidance is predicting that there will be storms today. And then we can see that our capping is going to be definitely higher, and that's because just the nature of night and nighttime cooling. As we look at our skew T chart, we see our dew point temperature spread is not very large, only 8 degrees. We see that we do have some capping, and then we see that our cape is not very large. Another thing we notice is that there is some dry air aloft providing buoyancy for our storms. And then we do see that we have somewhat okay lapse rates with the temperature decreasing 7.3 Celsius per kilometer, which is also going to provide lift for storms. Now, one of the issues for storms trying to produce tornadoes today is that they have a high likelihood of being elevated and not surface-based. We can see that our lowest free level of convection is much higher than our LCL. Our dew point actually increases as we go up in height in the lower levels. And then same with our temperature, and our lower lapse rate is not super high either. So that means that air closer to the ground will be stable and it will be harder for storms to be surface-based. Okay, looking at some of our climatological factors, we can see that we do have some excessive rainfall predicted in central Oklahoma and in the northeast today. This is not expected to bring a super large flooding risk, but something to be aware of. And then looking at our 6 to 10 day precipitation outlook valid through June 5th through the 9th, we can see that we are expecting above normal precipitation in pretty much the entire eastern and some western parts of the United States. This is going to be associated with our weather pattern and that large trough that we're expecting to pretty much encompass the entire western United States. And lastly, this is our 6 to 10 day temperature outlook, also valid from June 5th through the 9th. We can see that we are expecting lower than normal temperatures in the central plains associated with that trough and the cold air it brings with it. And then we're expecting to see warm temperatures behind it and in front of our trough associated with ridging behind and in front of our trough.